Oh, okay, so let's start with a new tutorial that is on BigQuery. Now, BigQuery is something which is becoming very important and was developed by Google Brain. So let's try to understand what is BigQuery. BigQuery developed by Google become big requirement of various companies. The reason for this is that the organizations increasingly rely on data-driven machine making and embracing an open data culture where the data is not siloed among multiple vendors behind multiple APIs with their limitations. Data warehouse like Google BigQuery, Snowflake, Amazon Redshift, and Microsoft Azure play a big part in driving the innovation. Today, we are going to discuss the BigQuery, an enterprise grade data warehouse based on Google Cloud infrastructure. Google BigQuery is a serverless, highly scalable data warehouse with a built-in query engine. The engine is powerful enough to run queries on terabytes of data in seconds and petabytes in only minutes. BigQuery began its journey in 2010 when the Google's several engineers started to build a data marketplace that wouldn't require users to download terabytes of data on their own machines. The logic which was developed is that when you have a big data, you want to move the computation to the data rather than move the data to the computation. So the engineers decided to build a computer engine and storage system in the cloud. BigQuery is fundamentally different from an premise cloud data warehouse like Redshift and Microsoft Azure. It is the first data warehouse that offers scale out solution. This means that the only limit in speed and scale is the amount of hardware in the data center. Google's enterprise data warehouse called BigQuery was designed to make large scale data analysis accessible to everyone. We will look into the how BigQuery can help to store big data like the small companies data can be that data we store in the spreadsheets, but the amounts of data grows to the gigabyte. We know that over the period of time the amount grows like anything, the amount of data grows like anything, and that is where the problem comes in storing the data. So we have to see that how we can manage it with the increasing data which may grow from gigabytes to terabytes to even petabytes. So you start a need or a more efficient system like a data warehouse, that because all that data isn't very useful unless you have a way to analyze it. We know that traditionally larger sets of data mean longer times between asking your question and getting answers, because it always takes depending on the computing power. So it takes some time for the system to compute that and give answers to the user. So BigQuery is designed to handle massive amounts of data such as log data and from thousands of retail systems or IoT data from millions of vehicle sensors across the globe. It's fully managed and serverless data warehouse which empowers you to focus on analytics instead of managing infrastructure. By design, BigQuery helps you avoid the data silo problem, which happens that when you have individual teams in your company having their own independent data sets, this can create significant friction or kind of a confusion between the analyzing the data across teams and cause challenges with data version control, because there may be that various data version are available and that may create confusion. So thanks to the integration with Google Cloud's native identity and access management, you can assign, read or write permissions to specific users, groups or projects and keep your sensitive data secure, all while still collaborating across teams. That is the way how we can secure our data. At the same time, it is available to everyone who wants to use it. So working with the data in BigQuery involves three primary parts, primary steps basically. So storage is first, then ingestion, that is data ingestion, and then querying that data. So Google handles running everything else. As discussed, BigQuery is fully managed service, which means that you don't need to set up or install anything else. And you don't require a database administrator also. You can simply log into your Google Cloud project from a browser and get started. Now first, let's talk about the BigQuery's storage. Data is stored in a structured table, which means that you can use standard SQL for easy querying and data analysis. So that's a big relief for the user. For example, let's say that you have some data that represents the sales for each of your stores in the last year. Now you could probably use a smaller database for data. It may be a spreadsheet or something of that sort. But what if you have thousands of stores and all that data needs to be stored in one single platform? And what if you want to get the revenue broken up by the product type, or maybe region wise, or maybe per time period also? That is where the problem comes in. So let's see what the solution for that. BigQuery is perfect for big data because it manages all that storage and scaling operations automatically for you. There are lots of ways to do that, as BigQuery is integrated with the rest of the data analytics platform from Google. You can upload data directly from cloud storage or stream data from cloud data flow. It can also be used to build an ETL pipeline using cloud data fusion. You can also import data from variety of file formats. So that's a big advantage. Once your data is in BigQuery, you are ready to start answering those questions. BigQuery supports the same structure, query language, or SQL that you may be familiar with if you work with ANSI compliant relational databases. You can bypass the ingestion and storage steps by analyzing the BigQuery public data sets. These are third party data sets that have been made public for anyone to query against. Google handles all this storage so that you can focus on your figuring out the answers to your questions. We already discussed that Google Big Data is a cloud-based big data analytics platform and that allows users to analyze vast amounts of data quickly and efficiently. It is designed and handle large amounts of data and enable fast SQL-based queries for data analysis. BigQuery utilizes or distributed architecture to parallelize queries, making it suitable for processing vast datasets at scale. It's a popular choice for organizations looking to analyze and gain insights from their data in real time. Let's understand some use cases of Google BigQuery. Number one, data warehousing. Now, storing and querying large data sets or anything that reporting purposes. Data analytics, running complex analytical queries on large volumes of data. Business intelligence, BI, building interactive dashboards and reports for data-driven decision making. Real-time analytics, performing real-time analytics on streaming data sources. This is very much required with the streaming data, which is continuously coming. Log analysis, analyzing and processing log files for insights and monitoring purposes. Predictive analytics, building and training large machine learning models for predictive analysis. IoT, Data analysis, analyzing data from Internet of Things, that is IoT, devices to derive meaningful insights. Financial analysis, analyzing financial data for forecasting, budgeting, and performance analysis. Customer analytics, understanding customer behavior and performances to optimize marketing strategy. Data exploration, exploring and visualizing data to uncover patterns and trends. Features of Google BigQuery, that is, as we already discussed, that ingestion is first, then preparation and storage, analysis, and ML, machine learning. So BigQuery is a fully managed enterprise data warehouse that helps you manage and analyze your data with built-in features like machine learning, geospatial analysis, and business intelligence. Serverless, no infrastructure management required. Google handles the infrastructure provisioning and scaling. Scalability, BigQuery can handle petabytes of data and automatically scales resources based on demand. Fast query processing utilizes a distributed architecture for fast parallelized query processing. SQL based queries. SQL supports SQL queries, making it easy for SQL users to get started. No additional knowledge is to be gathered because if you know SQL, you can use that. Real-time data analysis supports real-time streaming data analysis and built-in connectors to Google Cloud or Pub or Sub. Data encryption provides data encryption both at rest and in transit to ensure data security. Data sharing allows easy data sharing with external users and organizations. So whether the user is from inside or from outside, he can still use that, so long as he is able to log in. So machine learning integration integrates with the Google Cloud AI platform for machine learning tasks. Data visualization integrates with the data visualization tools like Google Data Studio or interactive visualization. Cost effective pay as you go pricing models based on the amounts of data processed. How Google BigQuery works and its architecture. Now, we also discussed that Google BigQuery is built on a distributed architecture that separates storage and compute layers. Storage layer. Data is stored in a Google Cloud storage in a columnar format. This allows for faster querying and analysis. Compute layer. When a query is submitted, BigQuery's compute layer dynamically allocates the necessary resources to process the query in parallel across multiple nodes. The data is read directly from GCS and processed in parallel across the nodes. How to install Google BigQuery? To use Google BigQuery, there is no installation process as such, as it is fully managed service provided by Google Cloud. To get started, sign into Google Cloud Console. Go to https://console.cloud.google.com and sign in with your Google Cloud account. Create a Google Cloud project, create or select an existing cloud project and enable the BigQuery API in the Google Cloud Console. Navigate to the APIs and services library, search for the BigQuery API and enable it. Load data into BigQuery. Load your data into BigQuery from various sources like Google Cloud Storage, Google Sheets, or streaming data from Pub or Sub. Run queries and analyze data. Use the BigQuery web console, command line tool, or integrate with programming languages and analytics tools to run queries and analyze data. Monitor and optimize performance. Monitor query performance and optimize your BigQuery usage for cost efficiency. Please note that Google BigQuery is a serverless service and users do not need to install it on the local machines. Instead, users interact with BigQuery through the Web Console, command line tools, or APIs provided by the Google Cloud. Thank you.